Right, now we're going to discuss creating a transition matrix between two bases, between two non-standard bases. So these are the same numbers as the last example from the last example in the previous video, first part of 4.7. So we found out that we can express the vector 1, 2, -1 in terms of these non-standard bases, and we found that the coefficients are 5, -8, and -2. So to use the new language, the coordinates of x relative to this new basis b1 are going to be 5, -8, -2, and the coordinates of the vector x relative to the standard basis ijk 1, 0, 0, 0, 1, 0, 0, 0, 1 are going to be just the numbers 1, 2, -1, right? So we write usually in terms of the standard basis. So the way we write vectors in general are in terms of the standard basis. So let's see, the computation that we made when we did this is we had 1, 0, 1, 0, -1, 2, 2, 3, -5 as a matrix, right? So we made that into the coefficient matrix. And then we had C1, C2, C3. These are the coordinates of x with respect to our basis B1, B prime. And this is how we got 1, 2, -1, which are the coordinates of x relative to the standard basis. So what this matrix did, let's call it matrix P because the book calls it matrix P also. So what this did is it turned, by multiplying by this matrix P, so if we had the coordinates 5, -8, -2 put in here, and we multiply it by this matrix P, we get the coordinates with respect to the standard basis S. So what this does is, now this means that matrix P is the change of basis matrix from, let's see, you would multiply it by something that's in B prime, and the answer, the result, is something that is written relative to the standard basis S. So P would be the change of basis from B prime to S. So let's say we want to just solve for these coordinate vectors. Instead of row reducing like we did in the previous example, what we can do is we can multiply both sides by P inverse. So then we would end up with P inverse times x relative to S. So if you multiply here, this is meant to cover up a mess. So if we multiply on both sides here by P inverse, and I know P inverse exists because these are linearly independent because they're a basis, then this turns into the identity, which keeps everything the same when multiplied. And so we could get the coefficients by just multiplying 1 to -1 by the inverse of P. This makes P inverse the transition matrix from, now we would multiply by the coefficients in S to, the answer would be something with coefficients in B prime to B prime. So the P inverse is the transition matrix from S to B prime. Okay, so here's an example. This example is like problems 15, 23, 29, and 33 in your homework. The way we set up, the way we try to create a transition matrix between two non-standard bases is we line up, so let's say we want to find a transition matrix from B to B prime. We list the vectors of B prime first as columns. So I'm going to start this by listing -1, 2, 2, -2. Then I need to list these as the columns of B. So I'm going to list these side by side, right? So these are going to be the columns of B prime, made of vectors in B prime. These are going to be -3, 2, and 4, -2. They go here. They're the columns of the second matrix. And then we're going to row reduce this matrix to the identity. And here, I will tell you in a minute what that row reduces to. This row reduces to -1, 2, -2, 3. So my matrix P inverse then, I computed P inverse here. P inverse is my transition matrix from B to B prime. That's my P inverse. So P inverse is given by -1, 2, -2, 3. Okay, so now that we have the transition matrix that takes vectors from B to B prime, if somebody gave us the coefficients of X in B, we could find the coefficients of X in B prime. So we would multiply, it's always left multiplication in these cases. So we would multiply, so this matrix takes things from B to B prime. So if we multiply by a vector with respect to B, so we're going to do it right here. So we're going to say this transition matrix P inverse can multiply the vector of the matrix of coefficients. This is a matrix of coefficients relative of X relative to B. So I'm going to take this matrix that takes things from B to B prime, multiplied by the coefficients with respect to B, and the resulting matrix will be a matrix of coefficients with respect to B prime. So that's what this coefficient matrix does with respect to B prime. So let's see, -1 plus 4, that's 3, -2 plus 6, that's 4. So that means the coefficients of X with respect to B prime are going to be 3 and 4. So that means I found, it says to find the coefficients of X with respect to B prime. I found it. The coefficients of X with respect to B prime are 3 and 4. What does that mean? It means that for me to get the standard basis, the coefficients with respect to the standard basis of this vector, I have to do, so X with respect to the standard basis according to this should be 3 times the first vector in B1, -1, 2, plus 4 times the second vector in there. So that means, so let's see, let's compute this. -3 plus 8 is 5, 6 minus 8 is -3, right? So according to this, the coefficients with respect to the standard basis would be 5, -3. Now we could compute this. I'm just verifying that my computation was correct. Here I was told that the coefficients of x with respect to b were 1, 2, which means the vector x, the coefficients of the vector x are going to be, let's see, 1, right? This 1 times v1 in b, so that's -3, 2, plus 2 times the second vector of b, that's 4, -2. So that means x with respect to the standard basis, if we try to untangle it that way, we get -3 plus 8, that's 5, 2 minus 4 is -2. Something went wrong. That's 6. Oh, this was 6 minus 8. This was -2. I did it wrong. And this way I get 2 minus 4 is -2 also. So so if I try to write this in terms of the standard basis, or if I try to write this in terms of the standard basis, I end up with the same answer. So this is my check to make sure that everything worked out the way it should have been. Now, you don't have to do this for any of the problems in the homework. I'm just showing you that it works. Now, in your homework, you're asked to find the transition matrix from B to B prime, and then you're asked to also find the transition matrix from B prime to B. That is just the inverse of this, right? So or you can do the computation all over again, so you can switch these, and if you reduce it, you're going to get the inverse of this matrix. You can also just find the inverse of P inverse, right? The inverse of P inverse is P. All right, so that's about it.